Welcome back, everybody. We've just got done predicting the chemical formula, so that will tell us how many atoms are in the compound. But now I want to be able to create a model that indicates electron transfer. And this is where those Lewis dot diagrams come in very handy, because we will be using those to show the electron transfer. So you have learned that atoms are composed of protons, neutrons, and electrons. The electrons occupy energy levels that surround the nucleus in the form of an electron cloud. The electrons that are involved in forming chemical bonds are called the valence electrons. That's why it was so important to understand what valence electrons were in Unit 2, because now we're going to use those for chemical bonding. Atoms can have up to 8 valence electrons. 8, 8, 8. That number is essential. We need to know the 8 valence electrons. We call that the octet rule. I might write that down if I were taking notes. These electrons exist in the outermost region and often called the valence shell, which is previous knowledge. The most stable atoms have 8 valence electrons. 8. When an atom has 8 valence electrons, it is said to have complete octet. There's that octet rule. Atoms will gain or lose electrons in order to complete their octet. In the process of gaining and losing electrons, atoms will form chemical bonds with other atoms. One method we use to show an atom's valence state is called the dot diagram. Lewis dot diagram. Do that dot diagram, and you will be able to practice drawing these in the following exercises. So let's begin. Let's practice following these so that we can create models to show electrons transfer. So, once you have the dot diagram for an element, you can predict how they will achieve the full shell. Here's one prediction. We have potassium, which is a +1 ion, and chlorine, which is -1. So we did the individual dot diagrams for sodium, or for potassium and for chlorine. This had one valence electron. So we draw an arrow to show the transfer here. Here's the final showing. Now I can predict the chemical formula with this, KCl. Now we know the chemical formula for magnesium chloride, so we said that there's 2 chlorines. We had to write 2 chlorines. This has a +2, -1, -1. These 2 electrons transfer, and then it comes up with this. And here's our chemical formula for magnesium chloride, MgCl2. So let's begin and let's do one together. Let's do sodium chloride again. So sodium chloride. Sodium has 1 valence electron because it is in group 1. So I make the dot diagram for sodium 1. Chlorine has 7 valence electrons because it is in group 7. So I make its dot diagram 1, 2, 3, 4, 5, 6, 7. Remember, unpaired electrons want to pair up. I would write that down probably somewhere. Unpaired electrons want to pair up. So sodium is going to lose the electron. So we draw an arrow there. And chlorine will gain that electron. Now I can count. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine has completed its octet. Sodium has also completed its octet because it no longer has that electron. So it drops in energy level. So we come over here and write the final Lewis dot structure, and it would look something like this. And now I check. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine has a complete octet. Sodium lost its 1, and so now it also has a complete octet because it dropped down in energy level. So now what I want you guys to do is together show dot diagrams and the electron transfer, and then predict the chemical formula. The reason why I taught you how to predict chemical formulas first is because you can use that to know how many calciums there'll be, your bromines there'll be, your magnesiums or oxygens. That will help you in the process of creating this diagram. So now, if you want to, I know it's hard to draw all of these on Google Draw, so you may use a whiteboard and just take pictures if you'd like. That's more than acceptable, as long as you show the electron transfer in those. Okay? Have a great day and continue practicing. We'll talk about this a little bit more on Tuesday. Thank you.